In this video, I'm going to show you how to work out your system's filtration rate. What I mean by filtration rate is not the flow rate. I don't want you to get it confused with flow rate. The flow rate is the speed at which water is moving throughout the entire system, whereas filtration rate is the speed at which water is moving vertically downwards through the filters. So the first step in working out your filtration rate is to work out the surface area of your filters. So to do that, what you've got to do is imagine that you're looking at the filters from a bird's eye view. So you're looking straight down, and what you've essentially got is a circle. To work out the surface area of that circle is a bit trickier than it is for working out the surface area of, say, a square. What you've basically got to do, and at first blush this formula might appear to be quite complicated, but it's really not, and that's the advantage of this being on a video, is you can rewind and replay this as many times as you want until you are comfortable with it. But what you've got to do is work out, the first step to working out the surface area of this is to work out how wide it is, i.e. the diameter of the filter. So in this example, I'm going to imagine that the filter is, say, 2.7. Let's imagine it's 2.7 meters in diameter. Now the formula now for working out this this surface area is its radius squared multiplied by pi. Right, so let's break this down. The radius squared, the radius is basically half the diameter. The radius is from the center point out to the edge of the filter. Yeah, so the horizontal line is the diameter. The vertical line would be the radius. So it's basically half of 2.7. So 2.7 divided by 2 is going to give us 1.35. 1.35 meters. So what we've got to do is plug that into that formula, radius squared. So it's 1.35 multiplied by 1.35. So let's do that. So 1.35 multiplied by 1.35. So the radius squared is 1.82. So it's 1.82. That's the radius squared multiplied by pi. And pi is, we can work to 2 decimal places with pi. It's basically 3.14. So let's plug 3.14 in there, and now we can work out what the surface area is. So 1.82, that's radius squared, multiplied by 3.14, which is pi. That comes to 5.71. So the surface area of that filter is 5.71 meters squared. So after you've done that, after you've worked out the surface area of the filter, all you need to do now is take the flow rate, which is the speed at which water is moving throughout the entire system, and divide it by that surface area. So for example, if there was a pool that had a flow rate of, say, 100, let's say it was 125 meters cubed per hour as the flow rate. So all you do is you would divide that flow rate by that surface area, and that would give you the filtration rate. So let's do that. So 125 meters cubed per hour divided by 5.71 square meters would equal 21.89, and the way it's expressed is 21.89 meters cubed over meters squared per hour. So running out of room there, I'll write it big down here. So it would be 21.89 meters cubed over meters squared per hour. So it's an unusual way of expressing filtration rate. As you can see, it looks a little bit different from flow rate, which is just meters cubed per hour. This is meters cubed over meters squared per hour. So 21.89 would be about right for a commercial swimming pool filtration system, because there's different rates of filtration. Low rate filtration is anything up to 10 cubic meters per square meters per hour, but that's not really used very much in swimming pools because it's too slow, and in order to process a meaningful volume of water, low rate filters have to be quite large in terms of its surface area, and so they're not used in swimming pools. Medium rate filtration is anything above 10 cubic meters per square meters per hour, right up to 25. So anything between 10 and 25 is regarded as being medium rate range filtration, and that's the rate that's recommended for commercial swimming pool sand filters. Anything above 25 meters cubed over meters squared per hour is referred to as high rate filtration, and that's not recommended because the velocity of water going through the filtration system is simply too quick. Because the thing with filtration is the slower the rate of filtration, the more effective it is. So you don't really want high rate filtration. It's just simply not as effective at doing the job as medium rate filtration, although many pools do tend to select high rate filters because they're smaller and they're cheaper. So one thing to add is, if you've got 2 filters or 3 filters, what you have to do is, once you've worked out the surface area of one filter, so 5.71, if all of your filters are 5.71 and you've got, say, maybe 2 filters, you'd have to double up, you know, so you'd have to double up that 5.71. If you've got 2 of them, it wouldn't be 5.71. You'd have a surface area of 11.42 once you take into account both filters. So what you would do is you would divide the flow rate by the total surface area of all of your filters, not just divide it by the surface area of one of your filters. Of course, if you've only got one filter, then obviously, you know, that one filter comprises 100% of your filtration surface area. So I hope that's relatively clear. I mean, as I say, it's one of the areas of the syllabus that a lot of delegates sometimes find quite confusing, because it's well, it looks confusing at first blush, but work your way through it slowly and methodically. Rewind the video, replay it as many times as you need to. It is important to know, as a pool plant operator, it's important to know what your filtration rate is. It's a pretty fundamental piece of information relating to the operation of your pool plant system. So I would recommend taking the time to figure it out. But what you need to know is your flow rate. If you don't know your flow rate, you will not be able to work out your filtration rate. And I say that because many commercial swimming pool filters don't know their flow rate and actually don't have the means to get their flow rate, because what you need is a flow rate meter. And we cover that in another video, how to work out your flow rate. I'll link to that in another video here.